All right. If you haven't done it yet or haven't noticed yet, the first thing you want to do is if once you import these files or drag these files in, you'll notice that you've got an error used typically for a circular linked list for the package. So the way you fix that, by the way, is you either put this in a folder over here called circular linked list, or you just delete this line and then everything is fine. All right. So with that, now we've a couple of things here. First off, your constructor is just very simple. You can pretty much leave it blank because leaving it blank is the essentially exactly the same as saying head is equal to null, tail is equal to null, and size is equal to 0. Because when you set up stuff with when you don't initialize things in the constructor, it gives them their default 0 value, right? Get node. This can be done for my videos. For those of you doing solitaire encryption, please feel free to add the following method. Private E, sorry, not private, but public E get int index, and then return get node index dot item, right? And that's just going to get the item from it that will be useful. You can also do a set if you need one, right? But I didn't include it because when I was originally making this for the other sorry, for Josephus, I didn't want to overcomplicate things. This one actually is all this needs to do is switch from false to true. And the reason that we even have this in the first place, okay? The reason we have this in the first place, this Boolean part of the add, is that this is a mandatory part of the collections class or the collection. Anything that is a collection, which is in Java, which is what we are dealing with here, anything that is a collection, um, which is, I believe, an interface, has these kind of mandatory functions that get that need to be implemented. One of them is add, which allows you to add an item to a collection. But a collection could just be like a pile of stuff or this disorganized mass as opposed to something well organized like a list. And this disorganized mass may not be able to accommodate you adding to it. So the add function should return true if it's successfully able to add, and false if it's unsuccessfully able to add. We put this as true because there are two cases as to what are going to happen when we add something to a list normally. The first is we add it to the list and everything works fine and dandy. And the other cases, we used up so much memory that things go horribly wrong and the entire program crashes, in which case we don't get the chance to return false. So why bother? Um, so we're always going to successfully add to an to our list. Uh, Cases where this will we'll see later in the semester. There are cases where we might return false, such as with sets, and those will return true if it successfully adds, and false if it can't because the item is a duplicate. Right? Do these five cases again. Um, our cases are we've got our out of bounds, which I'll simply put if bounds, right? That will leave that there. Node E node. And this changes based off of what it is for our for add versus remove, and that's the main reason I'm talking about this. Adding is equal to node, oh, sorry, new node, adding. Sorry, it just took me a bit of time to get into the flow today. Okay, if empty list case, right? Obviously, if I'm typing in code and I'm keeping it red, that means it's for you to fix because I'm not going to do it I don't want to give it all away. I want to do your assignment for you, but I do want to answer something very common in the structure that you'll have. If the front is fairly easy, so I'll give that to you. Index is equal to 0, right? This is the one I wanted to talk about, which was else if adding to the end, which means we're trying to add a new tail to the list, right? If we are adding a new tail to the list, that means that the index, in this case, you might be thinking I'm adding to the last index, so that should be size minus 1. But in fact, if index is equal to size, because we're adding to a new empty spot. Basically, we're adding to a spot that has not been taken. So that's the main thing I wanted to cover right there. And then you have an else. The main reason we do it like this structure over here, okay? Oh, don't forget to do this at the end, right? Because I have all in caps. Remember to increment the size. The reason I do it with this structure is because it avoids nested ifs, which can get really complicated. Okay. I do it this specific way because it keeps it one layer. There's no nesting involved, no function calls to other functions. The cases are very self-contained. Oh, there is one call to a other function, but that's only in the else case, and that's for get node. Okay. Now, the other reason I brought this up today is the list iterator. The list iterator, um, if you have the I'm working on the copy from Solitaire Encryption. If you use the version from Solitaire Encryption, you'll have this line. If you aren't working with Solitaire Encryption, you should have basically this. So if you're working on the Joseph's problem, it won't have that line about it being a different assignment. So this is so that's part of the reason I want to bring this up. If you're using the if you're doing Josephus, you'll be using this most likely. Okay. And if you're not doing Josephus, if you're doing the solitaire encryption, you're going to be just ignoring this file or this part. And the way you do that, and the way you can use this is, right, we have our, I'm going to just call this circular linked list, CLL is equal to new circular linked list. God, I love autocomplete. Okay. Circular linked list, blah, blah, blah. Thank you. Thank you, AI. That's great. Okay. Sometimes AI is very nice like that. I don't like using it too much, but I haven't configured this one to stop telling it. Anyway, all right. Didn't catch that I wanted to do generics though. Here we go. And now, what we're gonna do? And now, blah blah blah. We add more stuff. Blah 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 being over here. Okay. Once you're done adding your things, once you're done creating the circular linked list, we can create an iterator. I'm just going to call it iter is equal to new, and we don't say new iterator. We just simply say cll.iterator. And what this does is that this creates an iterator that's attached to this this instance, this particular object. And you are now able to use the hasNext method, the next method, and the remove method. And the Josephus problem basically will work like this, which is you say, while your CLL or your list.size is greater than 1, while there's more than one person left, right? We want to remove those. Okay, size? Do we have a size? We have a size attribute, I think. Yes. While it's greater than 1, in which case we keep going through this. Okay, and remove, and we use the dot, and the document talks about how you use the dot next calls and the dot remove calls. All right. Solitaire encryption. Will I be uploading to Discord to Discord? I could. Is that if you want me to, sure. Um, Now the solitaire encryption. All right. Um, I've gone through this with a few students already. Okay, first off, I've kind of hold on a second. I've talked about this in a previous lecture, but these two are done. You don't need to do this. Um, One student did point out that, hey, this only works with lowercase letters, and yes, that is correct. It will only work with lowercase letters. Okay, and now, the way so with our deck, then, if you um, if we have some, let's say, plain text string, plain text is equal to all shouty case, right? Say you take in some input from the user and it's in all caps, we can just replace that. Plain text is equal to plain text dot to lowercase, and that will turn it all to lowercase. Okay. So in case you're worried about that, but honestly, you should be, you know, that's not something you have to worry about, but that's how you would solve that issue. Anyway, you have these 5 methods you've got to implement in order to get this going. So obviously, the place you should start in implementing these steps 1 through 5 is starting in step 3. No, but seriously, that's where you want to start. Um, and as I mentioned to the people I've sat down with, what you want to do, and I guess I will use my magic cards here. Okay, is let's see. Let's go ahead and take out 1 lightning bolt. And we'll take out 2 lightning bolts. Our lightning bolts will be the jokers in this case, okay? Okay. I know it's silly, but let's go ahead and stop sharing, and instead you'll be able to um focus spotlight me. Okay. So for those of you who don't know, I occasionally play a game called Magic the Gathering, which is a collectible card game for people who say, "Hey, you know what? You know, drugs are too expensive. Instead, I'm going to spend my money on cardboard." Um, it's actually a lot of fun. It can be expensive, but I'm a red player mostly, which means I don't like spending money. I like beating my opponents essentially over the head with the equivalent of a sock full of pennies, using some of the both cheapest monetarily and cheapest resource wise spells in the game. Okay. Anyway, so the way I've talked about this is, imagine that we have a deck here, right? Then this is our normal deck of cards, and we are going through the deck until we hit a 27 or 28. Oh, sorry. Let me back up for a second. Step 3 is what we call the triple cut, where we want to find all the cards above the first joker and all the cards below the second joker and then swap them. So in this deck, in this we will simply replace. We're looking for lightning bolts instead of their jokers. Okay. Um, because this is what I have on hand. We do the best with we do the best we can with what we got. Okay. Now, what I've explained to students is, you want to imagine as though you've got this deck on a table and you have unlimited space. And yes, I know you can't see it. And basically, you have one hand behind your back and you are manipulating this deck as best you can with one hand, but you have unlimited space. And if you need to, you are making new decks. This is or new piles, I should say. This is the strength of of a um of a linked list. The ability to split up our the ability to split up. Okay. So I'm going to go ahead, and the way this is going to work is, I've got my deck over here, and I'm going to start out with a pile called top. Is this a lightning bolt? No. Is this a lightning bolter? No. 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 no, 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 and no, eh, no, no. There's a chain lightning. It's very close to lightning bolts, but not a lightning bolt. So we keep going until we hit our joker. In this case, again, a lightning bolt. Really, come on. I did my best not to stack this deck. I swear to God, this wasn't just an excuse to show you my magic cards uh, while under the guise of class. This is taking. There's a lightning bolt. Okay. So we keep doing this until the top card of the deck is a lightning bolt. And what I've been doing is that I've been removing index 0 and adding to the end of this deck. So we're done. This is a new link list called top. And basically, because I've been flipping them over, I've been adding them to the end over here. So just simply remove 0, add to end. So now I know this is I know this is a lightning bolt, so I'm just going to toss this over here. Now I'm going to continue until I hit the next lightning bolt. And technically I should do this one at a time. Come on. It's the pretty one. Okay, so it was the next card. And so we've hit the lightning bolt, the other lightning bolt. This will be middle. So now that I know this is, so we stop because we hit this other lightning bolt. And so I just simply add the next card. And now I know there's no lightning bolts in here. So until this is empty, I put this into the next pile. Now I've got an empty deck. Grab the card I dropped. Now I know I've got an empty deck. Top, middle, bottom. And I've got empty deck over here. Okay. So now what we do is we can simply combine these back up. I say basically for every card in here, I'm going to every card I'm going to remove, sorry, for every top card, I'm going to remove the card from the top and add it to this deck. Sorry, add it to the our now empty original deck. Now I do that, and I did that for bottom. Now I iterate over middle. I don't even iterate. I just simply say, wow, this is not empty. While the size is greater than 0. Remove the top card, add it to the end. And now we do that for these cards. And there we go. And so now we have top. And so now we've gone in our bottom. And then we have the middle between the two jokers, right? Here's the bottom. And then here is this other stuff between the two middle. And so we're done. Now this may seem overly complicated and annoying. Okay. Um, this may seem like really overly complicated. But I assure you, it's actually rather runtime efficient, despite it taking me a while to do. It is just simply 2n operations, because we look at every single card twice. Once when we're putting it in, and once we're taking it out. Surprisingly, if you are doing every single add and remove in that was constant time. And so that's how you should really be thinking about doing linked lists. Okay, if you can take advantage of of the fact that you're just simply doing the most efficient operations there, then yeah. This is my for those of you who do play Magic, this is my Burn Red Deck Wins Legacy deck. Play a I do a number of EDH decks. That is the major mass of stuff you see behind me. Um, those basically all that stuff is Magic stuff. I really need to donate a bunch of it to the Gamers Guild here, but I think I'm up to like 7 5-color decks at this point for EDH because I've always enjoyed playing 5-color. and I'm the kind of crazy person who knows how to do it with all basic lands. Um, so anyway, if you're interested in picking my brain on Magic, I'd be more than happy to talk about that sometime. All right. Oh, and last but not least, for Magic, the stack in Magic the Gathering is exactly the stack data structure that we are going to be learning about. All right. With that being said, anything else before I split us up into rooms? Okay. It is so weird that I don't have like any visual, you know, it always gets me that I don't get any visuals from the students. I can't meet anybody's eyes, so I have to stare at myself because I'm the only animated thing on the screen, right? Um, right. So before I continue, is there anything else that anybody wants to bring up? Otherwise, I'll split us up into rooms. All right. I'm going to go ahead and stop recording.